Hey guys, this is the Integrated Science Unit 3, Matter. So we are in the chemistry unit. We are on skill 1, atoms and elements, and this is part 3. So today we're going to talk about how atoms are similar of the same element and how they can differ. Okay, so you've probably seen this picture. It is the general idea of what we all think of when we think of what an atom looks like at the subatomic particle. And what you need to know, and we've said this before, but we're going to go over it again, the atomic number is the number of protons in the atom's nucleus. So right in the center, how many of those positive charges are there? It determines the identity of the element. So it never, ever, 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 ever changes for a given element. What do I mean by that? So let's say you look at the periodic table and you find oxygen right here. You'll notice this number right here is 8. That is the atomic number of oxygen. And it determines, so the atomic number determines the order in the periodic table. If you look at your periodic table, it's going 1 hydrogen, 2 helium, 3 lithium, and so on and so forth. So it's going in order of atomic number. And that number never, ever, 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 ever changes for the element. So oxygen will always have 8 protons in its nucleus. It cannot change no matter what you do. If you change the number of protons in an atom's nucleus, that is a nuclear reaction. You've probably heard of like a nuclear bomb or something like that. And that also changes the element. So if you change the number of protons, you change what identity the element is. And it's always a whole number. So you'll see there are 2 numbers on your periodic table. So if you're looking for the atomic number, I want you to ignore the one with the decimal and just look for the number of protons. If you will need to keep track of that, remember the atomic number, the number of protons, has to be a whole number because you can't have a fraction or a piece of a proton. You can only have 1 proton, 2 protons, 3 protons, 4 protons. You can't have 15.99 protons, right? It's a singular entity, so you can't have a fraction. So the atomic number is always the counting numbers, 1, 2, 3, 4, 5, 6, 7. That's how many protons are in an atom of that element. The next thing to know is the mass number. So the mass number is the sum of the protons and neutrons. So the protons and neutrons are hanging out here in the nucleus. So that's why we say the mass number is kind of like saying the total number of nucleons, or things that come from the nucleus. So you've got your positive protons in the nucleus and the neutral neutrons in the nucleus. So how many things are in that positive overall center of the atom? An element may have atoms with different numbers of neutrons, but it's still the same element. Because remember, what determines the identity is the number of protons. So even if you have a different number of neutrons in 2 different atoms, they could still be the same element. It depends on the number of protons. So here's a little formula to keep in mind. The number of neutrons plus the number of protons equals the mass number, or the total number of things in your nucleus. One thing you want to know is how to write stuff in shorthand notation. There's a lot of stuff to keep track of in chemistry, so it's nice to have everything clearly written in this nice little pattern. So the things you need to know about this shorthand notation is first, you always write the symbol of the element. Now, I do want to remind you that the symbol of the element may have 1 letter or it may have 2. This is chlorine, which has 2 letters. If there are 2 letters, the first letter is always uppercase and the second is lowercase. And that's key so that you know, is that second letter its own element or is it part of the first one? So since this L is lowercase, that's how you know it's linked with the C, and this is chlorine. All right, the top number over here is the mass number, and the bottom number is the atomic number. Now, some kids like to put like a line between this as if it's a fraction. It's not a fraction. Don't write a bar there. Also, some kids get really anxious because you have a bigger number on top. That's okay because it's not really on top of the other. It's just placed on top. It's not like part of the same unit. Okay, so the mass number on top, I just said not on top, but up high, and the atomic number down low. I'm going to show you in a second why we place it like that, even though it looks a little funny. All right, the other way to write stuff is hyphen notation. So the way you use hyphen notation is with a hyphen, which is those little dashes in English. So you write the element's full name, not the symbol, and then you put a dash and then the mass number. So if I were to write this element and this isotope of this element in hyphen notation, I would first write the element's name, which is chlorine, and that Then I would bring its mass number down. So this is chlorine 37, and that's telling exactly what type of chlorine it is. Remember, I don't need to tell the atomic number because it's understood. Chlorine is always atomic number 17. It never, ever, ever changes. So in hyphen notation, we just check the 17. We do write out the whole name of the element. All right, so let's try a sample question. What's the shorthand notation for palladium 108? The first thing you want to do is find palladium on your periodic table. And I know this is kind of annoying when you first are getting used to the periodic table, but I promise with time you get used to where elements are and you kind of find them a little quicker. So palladium is atomic number 46. It is a metal. So go ahead and find that on your periodic table, just so if you're looking for it again, you can find it quickly. So if we were to write this in shorthand notation, the very first thing I would write is the element symbol, which is Ed. Okay, so on top, we need the mass number. Now, there is something that is so incredibly important for these. This number on the periodic table, this number with the decimal in it, don't look at that for the mass. I know they're very similar and you're tempted to see two numbers here on the periodic table, so you want to put the two numbers here. Don't. Remember, the mass number comes from the end of the hyphen notation. So that top number comes from the hyphen. So 108 is on top. And then this number on the bottom comes from the periodic table, those counting numbers. So 46 goes on the bottom. Okay, so there you go. Top number comes from the name, bottom number comes from the periodic table. What about how many neutrons are in an atom of palladium 108? So if you remember just a minute ago, I said, I know it's really weird to see this with the bigger number on top and the smaller number on the bottom. Here's why. If you're trying to figure out how many neutrons, you're going to subtract the mass and atomic number to find the neutrons. You're literally doing 108 minus 46. Okay? Once you have that, you just type it into your calculator to figure out the number of neutrons. So 108 minus 46 is 62. So an atom of palladium 108 has 62 neutrons. What's the shorthand notation for iodine 130? So the first thing you want to do in these problems is find it on your periodic table. So iodine is a halogen. It's over on the right-hand side of your periodic table. All right, once you've found it on your periodic table, the next thing you want to do is write the symbol of the element. Iodine is an I, so a capital I goes on your paper. Now we're going to do our numbers to the left of the letter. The top number is your mass number, and that does not come from the periodic table. So that comes from the name, and the name is iodine 130, so 130 is going on the top. The bottom number is the atomic number. That you do get from your periodic table. So if you look at the periodic table right here, the only number that is the whole number or counting number, no decimals, is that 53. That's what goes on the bottom. So that's iodine 130 in shorthand. The other thing we need to know is an isotope. What is an isotope? And I said it briefly earlier in the video, so what was I talking about? Atoms of the same element, but they have different masses, are called isotopes. So see here, I have three types of carbon. I've got carbon 12, carbon 13, and carbon 14. They are all carbon, so they have the same number of protons in the nucleus, but their masses are different. So isotopes have the same protons, but different number of neutrons, and that's what gives the different masses. If you remember, masses are protons plus neutrons. Well, if the mass is changing, but you're not changing protons, you must be changing neutrons. So some isotopes of elements are radioactive versus some are stable. So for example, carbon 14 is radioactive over here. Now, there is always a set amount of carbon 14 in living things. So you are living, so you have a little bit of carbon 14 in you. And some of that carbon 14 decays into other substances versus some stays in your body. But you're constantly eating other living things, so you're taking in new carbon 14. So you maintain the same amount of carbon 14 that you always have until you stop eating, which is when you die. So that is what carbon dating is. We can figure out how long an organism has been dead based on how much carbon 14 is left because it's radioactive. It breaks down into smaller atoms. So if you have very little left, you've been dead a lot longer. So just a little interesting tidbit about different isotopes, carbon particularly, that is a very key thing for finding the age of different fossils and stuff like that. So we have a practice problem with isotopes here. Which of the following is an isotope of sulfur with 18 neutrons? Okay, key thing that we've done for all of these, find it on the periodic table. So once you find it on the periodic table, remember we are ignoring this number for now, and we are looking at this 16. That is the atomic number. And the atomic number goes on the bottom. So anything that doesn't have 16 as the atomic number, we can just get rid of it because we know it's not sulfur. The next thing we want to know is get rid of the ones that don't have 18 neutrons. So to find neutrons, I'm going to subtract. So 35 minus 16 is 19 neutrons. So this isn't the isotope we're looking for. 34 minus 16 is 18 neutrons. Ta-da! Now let's check my next answer just to be sure. 18 minus 16 is 2 neutrons. This isn't even possible as an atom, but that's definitely not the answer. So you have your answer. It is the fourth one. All right, best of luck with this section, and I will see you in the next set of notes.